Alright class, so today we're diving into a pretty pressing issue in environmental science: the impact of microplastics on marine ecosystems. Now, you've probably heard about the giant garbage patches swirling around in our oceans, but what's even more insidious are the tiny particles we can't see, the microplastics. These are plastic fragments less than 5 millimeters in length, and they come from a variety of sources. Firstly, we have primary microplastics. These are manufactured to be small, like microbeads in cosmetics or nurdles, those pre-production plastic pellets. Secondly, and perhaps more significantly, are secondary microplastics. These result from the breakdown of larger plastic debris through UV radiation, wave action, and other environmental processes. Think about a plastic water bottle slowly disintegrating in the ocean over decades. That's a major contributor to the microplastic problem. Now, these microplastics become part of the marine food web in a few ways. Smaller organisms like plankton ingest them, mistaking them for food. Then, these small organisms are eaten by larger ones, and so on up the food chain. This process, known as bioaccumulation, means that concentrations of microplastics increase as you move up the trophic levels. So, apex predators like sharks and tuna end up with significantly higher concentrations of microplastics in their tissues. The effects of this ingestion are still being researched, but studies are showing a range of negative impacts, from reduced feeding and reproductive rates to physical blockages in the digestive system. There's even concern about the potential for microplastics to act as vectors for harmful chemicals, transporting toxins into the organisms that ingest them. Incidentally, this issue isn't confined to marine environments. We're starting to see evidence of microplastics accumulating in terrestrial and freshwater ecosystems as well, though the focus of today's lecture is the marine impact. So, where do we go from here? Well, understanding the sources and the mechanisms of microplastic transport is crucial. Improving waste management practices, particularly in coastal areas, is a key step. And of course, developing biodegradable alternatives to conventional plastics is an area of intense research. It's a complex problem, but through continued research and innovative solutions, we can hope to mitigate the impact of these tiny particles on our oceans.